All right, today we are pulling back the curtain on one of the coolest magic tricks your computer performs every single second of the day, multitasking.
I mean, seriously, think about it for a second. Right now, you probably have a web browser open, maybe some music playing, your email is running. How on earth does one single machine keep all of that straight without just, grinding to a halt? It really does feel like magic, but it's actually an incredibly brilliant system of organization.
And probably the best way to get our heads around this is to imagine your computer's operating system as the head chef in a huge, busy, but super efficient restaurant kitchen. Every app you run, every window you open, that's a new order hitting the kitchen.
So, let's kick things off with what we're really talking about here, the multitasking illusion. Because, and here's a little spoiler for you, if your computer just has a single CPU core, it's not actually doing everything at once. It's just switching between all those jobs so ridiculously fast that it feels like it is.
Okay, so let's lock in our kitchen analogy. The head chef, the one calling all the shots, that's the OS kernel, the absolute heart of the operating system. The big board where they track all the orders, we're going to call that the process table. And that little ticket for one specific dish, with all the details like steak, medium rare, side of fries, that is the process control block, or PCB for short.
All right, so let's take a closer look at this whole order system. How does our head chef possibly keep track of every single thing that's cooking?
Well, first up, you've got the main order board, the process table. Think of this as the high-level, at-a-glance view. The OS can just look at this table and see every single program or process that's currently running. It's basically a master list that just points to where all the juicy details for each process are kept.
And those juicy details, they live in the process control block. So, if the process table is the list of all the order numbers, the PCB is the actual detailed order ticket itself. It has absolutely everything the OS needs to know to handle one specific task.
So, what kind of stuff is actually written on one of these order tickets? Let's dive in and look at the anatomy of a process control block.
Okay, first things first. Every single process gets its own unique number, called a process ID, or PID. It's just like an order number at a restaurant. This is absolutely critical so the OS never, ever gets your web browser confused with your music player. It's how the system knows which process is which. Next up, something called the program counter. Imagine our chef is following a really complicated recipe. The program counter is like sticking a bookmark in the cookbook. It tells the chef the exact step they were on before they had to stop and work on something else. This is how it can pick up right where it left off.
And what about the tools? Well, think of the CPU registers as the specific pots, pans, and whisks the chef was using for that one dish. When the OS needs to switch tasks, it takes a quick snapshot of all these values, saves them in the PCB, so when it comes back to that dish, all the right tools are laid out exactly as they were.
But wait, there's more. The PCB also keeps track of the process state. Is the dish actively on the stove? Is it waiting for the oven to preheat? Or is it just prepped and ready to go? It also notes the memory limits, how much counter space this dish is allowed to take up. It lists all the open files it's using, kind of like which page of the cookbook it's on. And, so important, it has scheduling info, like is this a top priority appetizer or a slow roast that can wait a bit? The PCB knows it all.
And here's the kicker. All this super critical information is kept under lock and key. The PCB is stored in a special, protected part of the computer's memory that only the OS kernel can touch. This is to stop some buggy app from, say, scribbling all over another app's order ticket. Can you imagine the chaos that would cause in our kitchen?
So we have our big order board, and we have our super detailed tickets. Now it's time for the action. How does our chef actually juggle all of this at once? This, my friends, is where we get to the great context switch.
So here's how the dance goes. First, a little timer goes off or something needs attention, so the OS hits pause on the current task. Then, it carefully saves everything about that task, the recipe bookmark, the tools it was using, all of it, right into its PCB. Next, it looks at the order board, picks a new task, and loads all the information from that task's PCB. And finally, it hits resume, and the CPU starts crunching away on the new task like it had been working on it the whole time. And the most incredible part of this? This whole four-step process, pause, save, load, resume. It happens thousands, sometimes tens of thousands of times every single second.
Now, it's not totally free, right? It takes a tiny bit of time for the OS to do this paperwork, but it happens so blindingly fast that we never notice. All we see is the seamless, perfect illusion of everything happening at once. That is the magic of the context switch.
So, when you put it all together, what have we got?
Let's zoom out for a second and see why this entire system is the secret sauce behind a smooth, modern operating system.
I mean, the PCB is the foundation for pretty much everything. It's what allows for smart scheduling by telling the OS which task is most important. It handles security by keeping track of which user owns the process. It's essential for resource management, tracking every bit of memory and every file. And get this, if a program crashes, a debugger can actually look at the last saved PCB to figure out exactly what went wrong. It's the central nervous system for every single thing running on your computer.
So here's the big takeaway, the most important thing to remember. Without this really elegant system, the high-level process table and the super detailed process control blocks, modern multitasking as we know it would just stop. It wouldn't be possible. You'd be back to doing one single thing at a time.
And that leads to a fun final thought. We've established that the PCB is a process's entire identity, what it's doing, where it's been, what it's allowed to do. So if you had a personal user control block that described everything you were doing and thinking at this exact moment, what information would you put on it? I'll let you think about that one. Thanks for tuning in.